Okay, S and R 0 0 means it will retain the current state. If Q is 0, it will retain 0. If Q is 1, it will retain 1. Whenever R is 1, it will reset the SR latch. Whenever S is 1, it will set the SR latch. When both are 1 1, the output Q and Q bar turns to logic 0 simultaneously, but it should not happen like that. Hence it is known as unpredictable behavior. Why it should not happen like that? Because Q and Q bar are complement to each other. If Q is 0, Q bar will be 1. If Q is 1, Q bar will be 0. So this is the function table which represents the functionality of this SR latch. These S and R inputs are applied directly to the gates and hence it is known as asynchronous input. There is no timing control in this SR latch, isn't it? There is no timing control. Okay. So as and when S and R change, the output immediately it will change as and now the inputs S and R change. Only thing what you have to remember here is whenever S is 1, R is 0, it will set the SR latch. Setting the SR latch means Q is 1, Q bar is 0. Whenever R is 1, S is 0, that time it will reset the SR latch. Resetting means Q is 0, Q bar is 1. Okay, so this is the function of the SR latch which is depicted on this function table. Next, this is a symbol S R Q Q bar. Okay, so this is one type of symbol. Another one is Q bar. No, so Q bar means a bubble at the output side. You can write Q here and put a bubble here. This is the second representation of the SR latch. So application of SR latch is a switch debouncer. Okay, how do you use the SR latch? Where is the application of the SR latch? So in our syllabus we have an application of the SR latch, that is a switch debouncer. Okay, so that one, the application of the SR latch, the first one shows the effect of contact bounce. These waveform, these are the effect of the contact bounce, and this is a switch debouncer. How the SR latch, this is a symbol of SR latch, you know it, no? SR latch, symbol of the SR latch. This is A point, this is B point, this is the voltage plus V volt, and here it is connected to a ground. These are S, R inputs. S is connected to A, R is connected to B, Q is the output, Q bar is the also output, which is complement of Q. Okay, so now here you can see this one, the effect of contact was figure A, you can see here as indicated here with the center contact. Where is the center contact? This is the center contact. The center contact of the switch, it is in the lower position. The voltage at terminal B is how much? It is plus V volt. The voltage at terminal B is at plus V volt, while the voltage at terminal A is at 0. The voltage at terminal A is 0. The voltage at B, it is plus V volt. Now if I move the center contact, move it from lower position to upper position, then the voltage at terminal B first becomes 0. Then by the voltage at terminal A becomes plus V volt. When the center contact moves, reaches the upper terminal, isn't it? Whenever the center contact is at B, B is at plus V volt. Whenever the center contact moves from the lower position to the upper position, the terminal A will be at plus V volt, and this will become the voltage at terminal V will become 0. However, because of this contact bounce, as a result of contact bounce, the center contact of the switch leaves the terminal A, causing the output voltage at the terminal to return to 0, and then upon returning to terminal A, causing the voltage terminal A to become plus V volt again. So what happens here? Opening and closing effect due to the springiness of the contacts It may occur several times before the center contact of the switch remains in its upper position. It is very important to note that the contact bounce, the center contact does not return all the way to terminal B. When it is switching from B to A, the center contact should not come to the point B. Okay, the contact bounce again occurs when the switch is moved from the upper position to the lower position. So the effect is normally undesirable. And how, when does the contact bounce occur? For example, when a push button key in the keyboard contact bounce may cause a system to respond as though a key was depressed several times in succession. Okay, so this contact bounce, these are contact bounce due to the springiness action of the switches, center contact switches. Because of that springiness actions, we have a contact bounce. Contact bounce means returning from 0 to 1, again 1 to 0, again 0 to 1, again 1 to 0. This is the contact bounce. This is undesirable condition. This has to be eliminated. How to eliminate this? It can be eliminated by using this SR latch. Okay, that only I am going to tell. So here what I told you students, that you can see this now. Whenever the terminal B, the center contact is at terminal B, B is at plus V volt, A is at 0. Whenever the center contact is at point A is at plus V volt, whereas B is at 0 or ground. Okay, so whenever the center contact moves from terminal B to terminal A, what happens? Contact bounce occurs. Contact bounce means because of the springiness nature of this center contact, the contact bounce occurs. It will go to A, again come back in between, again go to A and again come back in between. That is nothing but a contact bounce. Before the center contact reaches from lower position to upper position, it will contact bounce means going from 0 to 1, 1 to 0, 0 to 1, 1 to 0 and again settling at the VA terminal. Okay, again when going from A to B, here from A to B, so again it is going from A to B now, again 1 0 1 0, here again 0, next 1. It will then settle. Due to this is known as contact bounce. These you can see, 0 1 1 to 0 transition, 0 to 1 1 to 0 transition. Because of the springiness action of this center contact, it will go switch from 0 to 1 1 to 0, again 0 to 1, again 1 to 0. This is undesirable act. Okay, example of this when it happens whenever you press a push button key in the keyboard, that time you feel as though you will press the key several times. It is depressed several times. How to eliminate this contact bounce? How to eliminate this contact bounce? Okay, it is eliminated by using this SR latch. So what is the application? It is a very simple application of the SR latch, that is to eliminate the effect of contact bounce. A switch debouncer circuit and corresponding waveforms are shown here. This is a switch debouncer circuit and the waveforms of this, it is shown here. Okay, so positive logic, let us assume the positive logic, so that plus V volts will correspond to logic 1. Okay, ground will correspond to logic 0. Positive logic means what? Plus V represents logic 1. Okay, ground will represent logic 0. Okay, you can see here students, here there are two pull down resistors. Logic 0 are ensured at the S and R terminals of the SR latch whenever the center contact of the switch is not connected to either terminals A or B. Whenever the switch is open, okay, whenever the switch is open, okay, whenever this switch is open, no, that time what happens? S and R are connected to a ground through the pull down resistor. Okay, so when the center contact moves from the lower position to its upper position, the SR latch remains in its reset state until the center contact reaches terminal A, at which time the Q output of the SR latch becomes 1. Okay, so if S is 1, what happens? If A is 1, what happens now? S is 1. S means what? It will set the SR latch. Setting the SR latch means what? Q is 1, Q bar is 0. So how do you eliminate this contact bounce now? By using these pull down resistors, S and R inputs are ensured that they are connected to ground. That means they are in the previous state. Okay, so whenever the center contact moves from terminal B to terminal A, what happens? These two are in the reset condition. Because of this pull down resistor, they are connected to ground. Both are 0 0. Now when the center contact moves from B to A, this is in the reset state. SR latch is in the reset state, so contact bounce is eliminated. It will be in the clear baseline. Okay, so whenever the center contact moves from terminal B to terminal A, what happens? A becomes a plus 1, that is plus V volt, that is logic 1. So this logic 1 is applied to this S. Okay, whereas this R will be pulled down to ground, that is 0. So S is equal to 1, R is equal to 0, means Q is equal to 1, Q bar is equal to 0. So that is Q is equal to 1, Q bar is equal to 0. Can you see any contact bounce here? No, because of this action of the pull down resistors. No, whenever the center contact is moving from B to A, due to the pull down resistors applied connected to this S and R, they will be in the reset state. They will be at the ground state. Okay, so contact bounce is eliminated. Whenever the center contact is moving from terminal B to terminal A, SR latch is in the reset state because of the two pull down resistors connected to ground. So when it moves to A, contact bounce is eliminated because of these two pull down resistors. When it is moved to A is at plus V volt. Assuming logic 1 is connected to this S, R is connected to this ground. S is 1, R is 0, it will be in the set state. Now again, when the center contact moves from terminal A to terminal B, whenever the center contact is in between, what happens? SR latch will be in the reset state due to this pull down resistors. So when the center contact reaches to terminal B, B will become 1, A will become 0. So this B is connected to R, this will become 1, this 0 is connected to this. So it will be the reset state. When R is 1, it will reset the SR latch. Resetting means Q is 0, Q bar is 1. Okay, so it will be in the reset state. So in this way, by using these two pull down resistors, we can eliminate the contact bounce. Okay, this is S bar R bar latch. You can see here two NAND gates are interconnected. The output of the first NAND gate is connected as one of the input to the second NAND gate. The output of the second NAND gate is connected as one of the input to the first NAND gate. This is another type of latch, that is S bar R bar latch. How it is constructed? It is constructed by cross coupling the two NAND gates. Okay, its function table is shown here. Okay, and next second logic diagram of the S bar R bar latch is shown here. Okay, so this is a basic bistable element because it is having two stable states. Okay, you can also write this NAND gate as AND followed by NOT, isn't it? AND followed by NOT, and these are the symbols of this. If any one of the input to this S bar and R bar is made 0 while the other is 1, then the output of the NAND gates having the 0 becomes 1, isn't it? One of the input is 0 means it will become 1 here. NAND gate truth table, I think everybody knows, right? So here in turn applied input to second NAND gate, that also has a 1 as its other input. The output of the second NAND gate becomes 0. So here students, what you have to know here is, so S bar R bar latch is nothing but it's in SR latch we used to use NOR gate. Here we are using NAND. First I will give this 1 here 1. So if suppose I assume Q is 0 and Q bar is 1, okay, this 1 is connected here and this 0 is connected here. 1 and 0 is 0 here, we'll get 1 here. Next this 1 and 1 is 0, okay, and here 0 bar you will 1 and 1 is 1, sorry, 1 and 1 is 1, here you will get 0. So previously it was 0, you will get 0 only. Here previously it was 1, you will get 1. Okay, so it will retain the state. 1 will retain the state. Okay, let me explain you with taking Q as 1 and 0. Okay, one more. So here let me take Q as 1 and Q bar as a 0. I'll apply again 1 for S bar R bar. Okay, so this 1 will come here and this 0 will go here. This 0, Q bar 0 will go here. 1 and 0 is 0. 0 bar is 1. So what I will get? 1 I will get here. Next 1 and 1 is 1. 1 not of 1 is 0. What I will get? 0 I will get. So it is retaining the previous state or a present state, we can say. Present state was 1 and 0. So it is having 1 and 0. So this, whenever S bar R bar inputs are 1, that time we will have the same state retained. The current state or the present state will be retained. Is it clear? So next I will be explaining 1 and 0 again. So here when I assume Q is 0, Q bar is 1, I will apply 1 and 0. Let me see what happens. S bar is 1, R bar is 0. Okay, so this 0 will come here. This 1 will go here. 1 and 1 I will get 1 here. 1 bar I will get 0. Next 0 and 0 I will get here. 0 bar I will get 1. So here I am getting 0. Here I am getting 1. So what happens? S bar 1 in the S bar latch will reset the S bar R bar latch. I am telling you once again. Setting the latch means Q is 1, Q bar is 0. Okay. Reset means resetting the flip flop means Q is 0 and Q bar is 1. Always remember students, setting the latch means Q is 1, Q bar is 0. Resetting the latch means Q is 0, Q bar is 1. So whenever I apply in this S bar 1 and R bar 0, that time the Q will be 0 and Q bar will be 1. So having S bar is equal to 1, it will reset the latch. It will reset the latch. Next, taking the another condition.
Excuse me, ma'am.
Yes.
Ma'am, in this case, the outside.
S bar R bar latch has consisting of two NAND gates. Okay. Whenever S bar R bar is at 1, it will retain the present state Q plus. Whenever S bar is 1, R bar is 0, it will be in the reset state. Reset state means Q is 0, Q bar is 1. Next, whenever S bar is 0, R bar is 1, Q will be 1 and Q bar will be 0. That is Q plus and Q plus bar will be 1 and 0. And whenever S bar R bar is 0, 0, that time here we have 0, 0. That time Q and Q bar both will return to 1, 1 simultaneously. As we know that Q and Q bar are complement to each other. So they should not return to 1. Right? So that is the unpredictable behavior which will result if inputs return to 1 simultaneously. Next we have a symbols in this. So we can write two types of symbols, bubble and this bubble, S bar, R bar, Q and Q bar. We can also write here bubble in at the Q also and represent it as Q bar. Okay, so next gated SR latch. Gated SR latch is nothing but we have a additional two NAND gates A and B, and the second input of the A NAND gate and the first input of the B NAND gate is connected to enable C. This is a control signal. Okay, so here this control signal will enable this S and R inputs when they should be effective. Whenever the control signal is high, that time only if SR inputs changes, then only it will affect on the Q and Q bar. If control signal is 0, even if there is a change in the input of S and R, it will not affect on the Q output. Okay, so whenever S and R is 0 0, this is a simple S bar R bar latch which we studied right now in the previous slide. S bar R bar latch, this one, additional two NAND gates and a control signal C. So these are synchronous inputs because the inputs are controlled here. Okay, in S bar R bar latch there was no control over inputs. Here we have control over the inputs, that is control signal. Control signal will enable this S and R inputs to be effective. When S is 0, R is 0 and control signal C is 1, that time it will read in the present state Q and Q bar. When S is 0, R is 1 and C is 1, okay, so it will have Q is 0 and Q bar as 1. Whenever the S input is 1, R input is 0 and control signal is 1, that time Q plus will be 1, Q plus bar will be 0. Okay, when S is 1, R is 1, control signal is 1, both will return to 1 1 simultaneously. It is an unpredictable behavior which will return S and R to 0 simultaneously. Okay, so this is an unpredictable behavior. Irrespective of the SR inputs, if the control signal is 0, it will retain the current state only Q and Q bar. This is about the gated SR latch. You can put the combinations 0 and 1 and check the output Q and Q bar. Okay, so this is how the main thing here is. What is the difference between S bar R bar latch and gated SR latch is
1 and 1 net.
So
1 and 1 1. This is 0. This is 0 then.
So here you can put the combinations S and R and check the output. I was talking about the S bar R bar latch and gated SR latch difference. What is the difference? Here two additional NAND gate is there and one control signal is there. The control signal will make the SR effective. That means if control signal is 0, SR, if it changes, S and R changes, it will not reflect on the output Q and Q bar. Whenever the control signal is 1, that time only SR inputs will be affected on the Q and Q bar output. Okay, so this is about the gated SR latch.